I've been meaning to add a drill press to my shop for quite some time. Even though I have the Tormach CNC, it's still nice to have a manually operated drill press that I can use for large work pieces or just stuff that I don't really want to, have the hassle of bolting and clamping down into a vise inside the CNC. I've looked on and off for about a year, on Craigslist and other places, and I finally came across the Nova Voyager DVR. Now, the Nova is very different than other drill presses, and I'll get into that a little bit later, but first I just kind of want to give you a brief overview of what the unboxing and setup is like. I got the drill press from a local Rockler, and it comes in this huge cardboard box. I think the overall weight of this is about 350 pounds or more. The drill press itself weighs about 310, so it's pretty heavy, but I managed to get it inside on my own, mostly assembled on my own, just using a couple Harbor Freight furniture dollies. If you've ever put together a drill press, this really isn't any different. You've got the base, you've got the column that mounts to the base, you have the piece that slides over the column that ultimately holds the table, you have the table, and then you have the head that goes on top of the whole assembly. I was able to mount all of this on my own. Each piece really wasn't that heavy. It wasn't too heavy for me to handle, except for the head. I want to say that the head alone is at least 100 pounds. I didn't weigh it before I put it on, but I definitely needed a friend to help me lift this up on top of the column, mostly just because getting it up on top of the column was tricky on my own and because it was over 100 pounds. So that was the only piece that I needed help with. The rest of it I was able to do on my own. Here is the drill press fully assembled. The first thing you might notice is the LCD screen, all the buttons, and the knob. The Nova Voyager DVR is a very different drill press in that it uses a DC motor that's direct drive, so no belts, no pulleys, none of that stuff, and a microcontroller to control all the functions of the motor. I'm going to get into that a little bit later in the video, but first I kind of want to give you an overview of the drill press itself and kind of what to look out for when you're buying a drill press. You can get a better idea of why you care about these features. Before I get too much further in this video, I did want to mention that I am in no way affiliated with Nova, nor am I sponsored by them. I did buy this drill press on my own with my own money, and I have no affiliation with them, and I'm not being compensated for this video in any way. The Nova Voyager has about a 17-inch swing or so. The swing is referring to the distance from the middle of the spindle back to the column times 2. So if you have, let's say, a 10-inch swing, that means if you had a 10-inch board, 10 inches by 10 inches, you could drill anywhere on that board. You could put it up on here and drill in the dead center. So the swing is just double that distance, and the distance from here to here is about 8.5 inches, so it's got about a 17-inch swing. It also has this really, really nice cast iron table that has been ground flat, or at least, kind of milled flat. I'm going to try and measure the flatness of this table later, but it does look like it's actually a really nice job. And this is a pretty substantial table. It's not this same thickness all the way through. It does get a little bit thinner, but around all these slots, it is that full thickness, and down through this middle attachment piece, it's really thick. And it has this nice little removable plate. It is metal, but I might cut a couple out of acrylic or MDF just, to have around as a backup. So nice ample table. It does all the things like, it tilts and swivels. I think most drill presses are doing that now, to where the table can tilt this way, the actual table can spin around, and of course you have your up and down mechanism back here. The only thing I'm not really all that thrilled about is this thing is all so fancy up here, and it still uses the same kind of rack and pinion method of moving the table up and down that every drill press has ever used. So it still has that issue to where this rack is just kind of free floating in there, so it just kind of slips around. It's not the most elegant solution, but it definitely works. But when you get a rack that's this tall, it definitely can catch a little bit, and this top ring took a little bit of adjustment to get right. So I was kind of bummed that they didn't really move to a better system than that, because this has been used since the very first drill press ever. So a little bummed about that, but it works just fine. Generally speaking, from here on down, the drill press is a pretty standard drill press. It has the table that pivots from side to side, it has the handle that moves it up and down, it's got the base, it's got the column. It is pretty similar to every other drill press at this size, at this price range. I will say that the level of fit and finish and the castings and everything else is very good for this price range. It's actually a little bit better than what I expected to see from it, but generally speaking, it's a pretty standard drill press so far. So all the special stuff lies up in here. So let's start talking about what makes this drill press special and start with the quill. The quill is a pretty important aspect of a drill press. It is what allows you to drill into your workpiece. This particular drill press has a 6-inch travel from just under 2 revolutions of the handle, which is actually pretty nice and really good for a drill press even of this size. It has your standard spring return mechanism, which needs a little bit of adjustment. When I first got mine, these were really loose, and I need to kind of adjust it to get it to feel the way I wanted it to. It also has this little depth stop thing over here, which, you know, it's okay. I prefer using the depth stop up here, but if you're old school and still want to use this traditional depth stop, you've got one there, and it's, you know, pretty easy to adjust, but I don't really like it that much. Also, the other nice thing about this is it has a split collar for the quill. Some drill presses just use kind of a hole in the casting that this travels through, and then use a couple set screws on the side to basically give it tension and tighten it up. Well, with this, you actually have a split collar in the casting, so it actually tightens kind of like that instead, so it gives better, more even pressure, so you don't have as much play or slop. So overall, the quill and the spindle, you know, from here down, is very nicely built. As I briefly touched on earlier, this is a direct drive DC motor. It does not have your traditional motor with some pulleys and you have to go in there and change all the settings if you want different speeds. This is continuously variable anywhere from 50 RPM up to I think like 5,500 RPM. No belts, no pulleys, there's really nothing to do other than just kind of adjust this knob up front. It is a sensored motor, meaning it has a sensor for feedback to the controller. So if I say I want 200 RPM, it is going to try its hardest to give me 200 RPM. It's going to measure the load and measure the amount of power going into the motor, and if it starts bogging down or slowing down, it's going to apply more power, and it knows exactly where that motor is because of the sensor, so it's going to compensate for that. It has all sorts of fun things like load detection. You can also have stall detection, you can have vibration detection. All of those things can prevent you from having some kind of catastrophic accident. So if you go into a workpiece and it catches, this won't just keep trying to go. You can have it to where it'll actually detect that you're stalled out and stop before anything bad happens. It is a 1.75 horsepower motor that runs, I think, around 380 volts DC, and the motor controller and all that stuff is inside the head, so it's all pretty much self-contained, and it's all controlled with this little control panel in the front. Everything is operated with this little control panel right there. If you just want to turn on the spindle, it's as easy as pressing the on button. Off stops it, and then you can use the knob to adjust the speed, which can be done when it's on or off. And of course, it gives you a real-time feedback as to the actual RPMs and the amount of load of the motor. You can also set the depth, and you can have a depth stop. So right now I'm at 0. If I move the quill down, you can see that it moves out to 2 decimal places. And if I had a depth stop, you actually have a couple different options. You can have it to where it reaches the set depth and it actually stops the spindle. You can have the spindle keep going, or you can have it actually reverse a little bit when you pull out. So that's kind of cool. You also have your F1, 2, 3, and 4, which are just little preset buttons that you can program. So F1 is like 250 RPM, 2 is 900, and so on. If we click the menu button, we can actually go into the menu, and this is all the features. I'm not going to go into every single feature of this drill press because, quite frankly, this video would be really, really long, but it has a lot of kind of interesting little things like self-start. If I set self-start to on and then exit out, as soon as I go down on the quill, it starts, and then as soon as I let go, it stops. So it's kind of nice if you're doing something repetitive over and over and over. Think of like a production environment. All you need to do is just grab this handle, press down, it starts, and then it turns off. And all of these settings can actually be saved to your favorites, which is kind of cool. The depth stop feature is also pretty interesting. If I go into the menu and select this second item, user set depth, I'm going to have this set to, let's just say, 1/4 inch. And so we're going to confirm that. And so the set depth is 1/4 inch. We're currently at 0. And I'm going to go ahead and hit on. And as we go down, the depth has been reached and everything turns off. And then it just goes and resets. So I can do this once again, and you can hear a beeping that indicates that we're getting closer and closer to the target depth. Now those features might seem maybe a little bit gimmicky to you, and quite frankly I don't really use them all that much. However, the one thing that I do use quite a lot is the ability to set the speed based on the material. So if we go into the speed chart here, we can actually select the bit that we're going to use. So you can do hole saw, spade bit with spurs, countersinks, and we can select all these different bits. So if we just go up to, like, let's say a hole saw. So we select a hole saw and we can actually set the size. So I'm going to do a 2-inch hole saw, and then you can select the material it's going into. So we're going to do aluminum, and it's set to 250 RPM. We can confirm that, and now everything's ready to go. So instead of changing belts, you can just simply specify what bit you're using, at what diameter, and what material you're drilling into, and it will go ahead and set the appropriate RPM. This menu system is actually chock full of a lot of various things. I mean, it even has a pilot hole mode. If you're drilling into a really hard material, you can actually do a pilot hole and then it'll ramp up the speed. It even has a tapping mode that I need to update the firmware to get the full use out of the tapping mode. But since this can detect the load and also self-reverse, and it also knows where the quill is, you can actually have it to where when you go down, it taps, senses the load, does a chip breaking, and then when you pull it back, it will actually reverse out. So there's some really cool modes set up in here that I just haven't really gotten into yet. You can set your favorite speeds, you can choose the direction, and the setup menu is almost just a little too crazy. You've got all the drill parameters, max speed, you can do the units, you can calibrate the depth, and then you even have all the motor parameters in here, which I'm not really even sure why you'd need to choose the PID settings for the whole thing, but there it is. You can see the DC bus is running at 360 volts, so it's a pretty cool thing. You even have temperature measurements on the motor and the heat sink. So there's a lot of stuff to play around with in here. Before I break out all my measurement tools and measure the run out and all the other stuff on this, I wanted to show you just kind of how the speed range works and how the speed adjustment functions. Right now I've got it set to 50 RPM, which actually I've used before doing like countersinks or stuff with plastic that you just kind of want to go really slow. You know, stuff that I might normally just use a hand drill or do by hand. It's actually kind of nice that 50 RPM actually works pretty well for this. So this is the lowest end of the speed range. So if I turn it on, you can see that, of course, the chuck starts moving. Now, with a normal drill press, if I were to grab the chuck, it would stall it out. 50 RPM is really slow, and there's really not a lot of torque down this low. With the Voyager, it's a little bit different. So as I grab the chuck, you can see up here on the load meter that it is applying more and more power to compensate, because it senses that we're not getting the target RPM. It actually says low up there, and it actually will apply more power to speed it up to get closer to that target. There is also a setting in here that you can once again detect if it's a stall, and it could just shut off the spindle so you don't hurt yourself or tear into your workpiece. So I thought that was pretty interesting. And it will do this, of course, across the whole speed range. So as soon as you plunge down into something with, let's say, a Forstner bit or a hole saw, it will actually compensate the amount of power to actually get you a good bite into that. And of course, since I'm here, it's probably a good idea to show you how quiet this drill press is. I was expecting it to be a little bit quieter. It's not exactly loud, but it definitely has some noise just from the motor itself moving. When it's off, this is as quiet as it can be. It just feels like perfectly smooth. It just feels like there's a shaft in bearings. You can't feel anything. And if we turn it on, you can definitely hear a little bit, and let's just kind of go up through the speed range. I'll go all the way from 50 RPM all the way up to 5,500 RPM, just so you can hear what it sounds like. So this is about 300 RPM, and it's still pretty quiet. So now we're about 1600 RPM. It's definitely a lot louder, moving quite a bit faster. 2600 RPM. I'm speaking maybe a little bit louder to compensate from the noise of this. And once we start getting a lot faster, it's going to get a little bit louder. So that's 4000 RPM, and it is really humming along. So let's go all the way up to 5500. So 5500 RPM is pretty darn fast for a drill press. So yes, it is loud, but most drill presses are not going to be that well balanced to get all the way up to 5500 RPM. So there's that. At first I was a bit reluctant to purchase a drill press of all things that needs firmware updates, that has a screen that you need to boot up. So let's just assume all of that is just non-usable gimmicks. So is it a good drill press at the end of the day? Well, let's start measuring it and testing it out to see if it is. The first thing I'm going to do is a nickel test. I'm going to put a nickel on the table here and see what kind of vibration we get. I'm going to see how well balanced this is at 5500 RPM. I'm feeling a little bit more confident, so I'm going to do both a penny and a nickel right here on the table, if I can get these balanced. So there you go, standard US penny and a nickel. Let's ramp this up to 5500 RPM. So what's interesting is there was a little bit of movement between these two, but it was actually the air coming off the chuck. There was actually a nice breeze coming off of this whole area just from the chuck spinning. But as you can see, they stayed perfectly fine. So I think it passed that test. The next thing I'm going to test is runout. Runout is essentially how much wobble is there, how true does this run. So I want to not only measure the chuck itself, but I want to remove the chuck and measure the spindle for runout, and then I'm going to put a hardened rod inside the chuck, move the quill up and down, and measure just how parallel that whole thing is. So let's start with measuring the runout of the chuck. To measure the runout of the chuck, I have this stainless steel shaft chucked up into the chuck, and I've got a dial test indicator mounted on the table here. So I'm going to move the test indicator into place. I'll go down on the low side. And so let's see. So it looks to be, I don't know, maybe about 7 or 8 thousandths out of whack. So a total run out for the actual chuck of, like, let's just call it 8 thousandths is really not that bad. Online I was seeing that, 5 is like really good, anything under 10's pretty okay. I did actually swap this chuck out a couple times to see if it was the chuck, and all the chucks I have pretty much measure the same amount. So this isn't amazing by any means, but it's really not that bad. There's really not that much run out here. So let's take the chuck out, remove that from the variable, and measure the spindle directly. Now I've got the chuck removed, and I've got the test indicator resting directly on the inside of the spindle here. There we go. Move that to roughly 0. Now I can't really move this by hand, so I've got it set to 50 RPM, and I'm going to turn it on. That's much better. So you might not be able to really see the needle moving, but I'm moving about a total of 1/4 or 1/2 thousandth, or 1 tick. So yeah, 1/4 or 1/2 thousandth total. So that's actually really good. So all the run out is going to be in the chuck. So if I was going to get a better precision chuck, I would basically eliminate almost all of my run out. Before I close out the video, I wanted to crack open the top of the drill press just to see what's inside. So I've already loosened all these screws, and then this piece just kind of comes away like that. And here is the inside of the drill press, and it's pretty cool. So you've got the motor here, this whole section, pretty much all the way down is the motor. You got the control panel on the front, and then back here is the power supply, and that thing is pretty beefy. There's a huge inductor, so that's probably going to be the AC to DC power supply section, and then you have a bunch of relays and some other stuff, and a really big heat sink, and then over here is going to be the optical encoder. No, it actually might be a Hall effect. I see a couple possible Hall effect sensors on there, so it doesn't look like it's optical, but there's 3 of them across here, so that's actually pretty neat. Overall, the build quality of this is fantastic, so yeah, that's what the inside of it looks like. All in all, I'm pretty happy with the performance of this drill press so far. I've drilled titanium, 4140 stainless steel, aluminum, and of course wood. This is really marketed as a woodworker's drill press, which I think is way, way overkill. This motor has so much power, well beyond what you would ever use for wood. I'm sure you could take like a 2-inch or a 3-inch Forstner bit and go straight into hardwood, no problem. I was able to do titanium without any issue whatsoever, so that's good. It also measures really nicely. If you need super high precision for metalworking, this is not the right chuck for you. But if you think about it, every drill press you buy is probably going to have a very similar chuck. And truth be told, I measured the runout of this chuck and all the other chucks I have on my CNC machine. They all measure about the same. You're just going to get some runout with the chuck, and that's kind of to be expected. If you need a really high performance chuck, you can definitely buy a Jacobs or whatever else and get rid of that issue. But for woodworking, it's just really not going to be an issue. Other than that, I really like the fit and finish. I really like the build quality, and I'm very eager to use all the features here. There is a firmware update, and I didn't really cover a lot of my little quibbles with the interface in this video because the firmware update seems like it fixes most of those. This is still just an early version of the firmware. There's a USB jack right underneath there, and upgrading the firmware should be actually pretty easy. So I'm going to cover that in the second video and maybe do a little bit more of my impressions about the software once I get tapping and some of the other stuff working on it. So really, overall, I like it a lot, and I think it's a good value for the money. It is one of the more expensive drill presses out there, but it's a huge and well-built machine, so I'm okay with that. So the only thing left to do is pull off all these stickers, and thanks for watching.